These three problems are the most missed from the functions test in this class. Number 2 is the most missed, then number 1, then number 11. You can add these examples to your notes. On number 2, we want to decide whether or not each relation in the graph is a function. Every point or line or picture in each graph is included in the relation and has to be taken into account. Remember that a function means every input has just one output. So what we want to do is check each input or x value and make sure that there's only one output. First, we can check the value for -2 for x. We can see there's only 1 point down at -3 for y, which means there's only one output for that input. This is called the vertical line test. We can check each line where there's a point and make sure there's only 1 point on that line. Since there's only 1 point on each vertical line we check for each x value, that means that this is a function. We can use the vertical line test also on solid lines, like the upside down triangle. If we draw a vertical line and it touches in 2 different points on the top and the bottom there, that means that's not a function because that input had 2 outputs. We can check the third one with vertical lines, and as long as no matter where we draw a vertical line, it only touches one place at a time, that means it is a function. The bottom one on the left is a little tricky. We can check vertical lines, and it looks like it touches in 2 places right here, only the bottom circle is empty or open. Whenever we have an empty circle, that means that point is not included. It's an inequality, like greater than. Anything greater than that point is included, but the actual point is not. So the top point is touching, but since the bottom is empty, it does not count as touching. So this would still be a function, since in every other place we check, it only touches one place at a time. The middle on the bottom does not pass the vertical line test, since it would touch top and bottom at the same time, so it's not a function. And the last one, we have one vertical line at -2 for x with 2 different points, which means 2 different outputs, so that's not a function either. On number 1, we want to be able to identify whether or not it's a function based on the ordered pairs list or the mapping with the lines drawn from input to output. Remember, each input for x has to have just one output for y. The only time on a list of ordered pairs that we would have an input with more than one output is if we have a point and another point that have the same x value. Since each x value is different on this first relation, that means it is a function. There are no repeats. The same is true on the second relation. Look at each x value, and as long as they're all different, that is a function. When we have a mapping, we just have to make sure that each element of the domain, which are the x values, has only one line mapping it to one output. So since each of those 4 inputs has only one output, this is a function. The very last one is not a function because even though the top only has one output, the bottom input has 4 different outputs, so that's not a function. The last one, number 11, we want to identify which graph matches the story. Well, we have to find places where our graph should be increasing, decreasing, or staying constant or the same. So let's go through the story one part at a time. First, we can see that Jane is hiking towards her campsite as we keep track of the distance to the campsite. Well, as she's getting towards her campsite, that means closer, so the distance should be decreasing. Then she sees a snake, and when she sees the snake, she runs the other way, which means farther away from camp, so the distance to camp should be increasing. When she sits down to rest, she's not getting closer or farther away, so the distance should remain constant or the same. The only graph that shows decreasing, then increasing, and then staying constant is the third one, so that graph matches the story. Part B, we have the story of Ravi jogging. Ravi first starts by running faster and faster, so the speed should be increasing. Then he hits a comfortable space and he runs at the same speed for a while, which means his speed should be staying constant or the same. After he's been running for a while, he slows down to a stop, which means his speed should decrease to 0. The only graph where we see his speed increasing, staying constant, and then decreasing to 0 is the second one.